I just have one question. You didn't really expect me to understand any of this, did you? And the whole place erupted in laughter. I was born and brought up in the city of Cambridge in England, and I was the first person, and my mother was the oldest of 8 children. And her father died when she was 14 years old, and she was then sent out to work to support the family. And my father was also left school when he was 14 for quite different reasons, and he had two brothers. And so they were the people who brought me up. I have many passions for building things. My dad, long before I was born, had a big role in building our house that we lived in. He didn't do the bricklaying, but it was a very nice house, and he did much of the construction personally when he was a bit out of work. And as I grew older, he encouraged me to learn how to make things. And he, in fact, his early profession was as a carpenter. And so I learned a lot about carpentry and how to build things out of wood, some of which I still have. But as I grew older, I became very interested in making things. And one of my early passions was building model aircraft. And I remember building, initially I would build these hang gliders, and some of them had a wingspan quite big. I also learned about diesel engines, little tiny diesel engines that you could put in an aircraft, and it would then fly by itself. And I also learned how to launch gliders. And so I had, this was a preoccupation because it was actually a competitive event. And I used to go out to these big model aircraft events, and I would fly my glider. And the question is, which went the furthest and which was able to fly for the longest? So I got very interested in that. I also very much liked photography. And I learned a lot about photography, and I started off with a very simple camera, and then as time went on and the cameras became more sophisticated, and I learned not only how to take photographs, but I learned how to develop the negatives, and then how to use the negatives to take prints. And again, I still have some of those left. I have some photographs that I must have taken when I was about 12, 14 years old. So I got very passionate about building things like that. But my dad, who was, a very, very interesting man, and very sort of encouraging for his son in particular. And so because he was in the sort of building industry, he knew a lot of people who had different disciplines, like a plumber, for example, or an electrician. And so he would give me a job. He would get me a job of learning how to do plumbing for maybe 6 weeks during the summer, or various other occupations like that. That was very interesting because I still know how to do plumbing in my house because he wanted me to learn all that stuff. So I was always very encouraged by all that. The single most important thing that had a huge impact on my life was that he thought I should learn about electronics. And he knew someone who, at a very early stage, this was maybe when I was 16 or so it was the late 50s. He knew someone who was interested in building all kinds of specialized electronics. And his name was John Barron. I still remember him very well. And so he said, well, the first thing I have to do is to make sure that you know about, how to design electronic circuits. And so he spent a day designing all these different circuits, and he would take me through it. And he said, well, is this okay? And he said, well, that's maybe as far as we can get. He said, because to go any further, you would need to know about calculus. I said, of course I know about calculus, because I went to this fantastically good school. It's called the Perth School, which I was there for 12 years, and it had a huge impact on my life. So he got very excited, and then he started to go through, how you calculate things using in calculus. And I came away with this incredible knowledge of things like that. I was still at school at the time, but I managed to find a place where I could get things like vacuum tubes for free or for very little money, and I started to build all these different things. And I think the most important thing I built was an analog computer. It was actually a computer that could do calculations. And to see how it was working, then I had to build an oscilloscope. So I built an oscilloscope as well. But the thing that I still remember very vividly is the fact that I could use my computer to do first or second order differential equations. And I mean, I think the school still has it, because it was really quite interesting. And the biggest outcome of all this was that the Perth School, which was founded in 1615, was a wonderful school. It was the street that it was on was christened Free School Lane, because the people who founded it decided that up to 100 boys could attend this school for free, because they had left a lot of money. And so it's still called Free School Lane. But anyway, so the school had, some time ago had moved to a new building, but it went to yet another big building on a very big piece of land where there was enough space to have football fields and cricket and all kinds of things. But if you consider yourself to be a high-level school, then you have to have someone with the royal family to open it. And so they decided that Princess Alexandra should open it. And she's still with us. She's, I think, 1 or 2 years older than I am. And she was asked to open the school. And so she said, I'd be glad to do that, but she said there were 1 or 2 conditions. I want to talk to several of the boys in quite different disciplines. And my discipline already was physics. And so the school selected me to teach her something about physics. So of course I had to show her my analog computer. And I have photographs still of my explaining how it works. And the head is very close to mine as I go through how it all works. And so I explained about differential equations. I explained about my computer, how I built this. And she listened very, very intently. Because at the end of all this explanation, everyone, and it was the hall was filled with people. And then the headmaster who was running it said, and Your Highness, do you have any questions? And then she looked at me, she said, I just have one question. You didn't really expect me to understand any of this, did you? And the whole place erupted in laughter. And then everyone laughed and laughed and clapped, and that's my memory of this. That was one of the great experiences of my life. And I think I remember that when I first went to kindergarten, the school that I went to was called Miss Chandler's. It was about half a mile from our house. And my dad said, well, it's time you learn to ride a bike. And this is when I was about 5. And so he taught me how to ride a bike. And that's when I started, when I was 5 or 6 years old. But then from then on, I rode my bike a lot. And I would ride my bike to to school every day, and subsequently, every day until very recently, I've ridden my bike to University of California, Berkeley. Now, the famous bike ride was for 1,300 miles, and it took me 6 weeks and 3 days. And it was an incredible experience. And first of all, I took a ferry across the channel to Belgium, and then I cycled across Belgium until I got to Germany, and then I cycled up the River Rhine, and that was the longest part of the trip. And then subsequently, I came back a little bit till I got to the River Loire, and the River Loire leads you into Luxembourg. So I cycled across Luxembourg, which is a small country, and then I ended up in the Netherlands, and then I made this big loop around the Netherlands, and I have very fond memories of many villages and very interesting towns and cities that I visited. I used to go to museums a lot. And the interesting thing was that in those days, you could stay in these very inexpensive hotels. And in fact, there was a whole series of hotels. I can't remember the name of them. But you could stay in one of these hotels for a night for what was at the time even a very, very small amount of money, I mean, 1 or 2 shillings, so just, a tenth of a pound or something. And they have very good food. And one of the things I remember about the food was that, if you bought you bought the main dish because I was hungry, and you paid a certain amount of money for it. But all subsequent helpings were free. And so if you just cycled 100 miles that day, you're a pretty hungry kid. And I was 20 years old at the time. So I would always go back to get my second helping and my third helping and even my fourth helping. And all these ladies were so impressed that I could eat so much of their food. And they said, "Why do you keep coming back for more?" I said, "Well, it's delicious food." So that was an incredible experience on me because I met lots of different people and people from different countries, and it was interesting that they were always very encouraging. I mean, the fact that this 20-year-old boy was willing to cycle all this distance just to come and look at their country. And I particularly like riding my bike along rivers, and particularly the River Rhine, for example, or the River Loire. But it was the people I met that I think had the greatest impact on me. And I realized, how important it is that you talk to people, that you share ideas, that you want to learn from them. And I didn't have much in the way of languages at that time. I knew Latin and and I knew French, but I didn't, for geographical reasons, I didn't go to France. I mostly went in Germany, and my German was very limited. But most of the German people were very kind, and they spoke English, really quite well. And in the Netherlands, they certainly talked a lot of English. So it was a very memorable thing for me, and as you can see, I remember it very vividly. I think it's because I became so interested in all the things I had learned, particularly things like electronics. And I thought, to understand how electronics works and what you can do with it, then I think you need to know about physics. And also, very importantly, I had a very, very good physics teacher at my school, at the Perth School. In fact, I had very good teachers in both physics and chemistry, and importantly in mathematics. And all this sort of pushed me in this direction of going to do science. And so for my undergraduate work, to get my degree, and at the time a bachelor's degree in the UK was 3 years, so I basically studied physics but in addition, also mathematics and some chemistry, because you had to have some breadth. So that's really where it all came together, because I learned at this incredibly high level when I look back on it. I think that I'll tell you a little story, that when I came to the United States and became a professor, when I first started teaching physics, I was stunned at how little mathematics that the students knew compared with what I had learned at the first school. And it really, I mean, I had to sort of simplify my courses because otherwise they weren't going to understand it. I'm not sure you should publish that note, but it's true. My thesis advisor was Brian Pippard, later Sir Brian Pippard, and he said, well, I'm trying to find a really challenging thing for you to work on. And he said, I've come up with this idea that would require you to measure a voltage of 10 to the minus 12 or 10 to the minus 13 volts at a time when the state of the art was 10 to the minus 9 volts. So I thought, wow, is that humanly thinkable? So anyway, I pondered it for a while, but then there was an experience that set up my life in a sense. There was one other student in the same group working for Brian Pippard, but he was 2 years further along from me. And his name was Brian D. Josephson. And Brian Josephson, if there was ever a genius, he was a genius. And when he was in his first year as a graduate student, I mean, he was really a theorist, he came up with two very simple equations, mathematical equations, called the Josephson equations. And that was in 1962. And in due course, he got the Nobel Prize for this invention. But anyway, I got to know him very well. And I thought at the end, he gave this talk, 1 hour talk. And I thought at the end of it, gee, why aren't I working on this? It's just totally fascinating. And so the thing that was particularly interesting is that literally the next day, Brian Pippard, there were two Brians, Brian Pippard and Brian Josephson. Brian Pippard came into my lab and he said, John, I think I have the solution. And it was based on what Josephson had talked about the previous day. And he showed me, he wrote, you know, in those days you had a blackboard and a piece of chalk. He said, if you do this, you will have a sensitivity of 2 times 10 to the minus 15 volts, which is much better than I needed for my experiment. But it turned out that, so I immediately started to think about how you do this. And it turned out that the way that Josephson had explained you should do this was beyond the capability of the Royal Society London Laboratory at the time, because they didn't have the equipment. But to cut a long story short, I mean, I was getting very frustrated because I knew what to do, except we didn't have the tools to do it. And then every day we had tea at 4 o'clock, because that's what you do. And I was talking about how frustrated I was that we didn't have the equipment to do what I wanted to do. And then one of my fellow students, his name was Paul Raitt, he said, well, you know, you've been messing about with bits of niobium wire and you talked about soldering things together. He said, niobium wire has an oxide layer on it and solder is a superconductor. Why didn't you put a blob of solder on a piece of niobium wire and see what happens? So I thought, well, that's an interesting idea. And so I rushed back to my lab and I did what he suggested. And I cooled it down in liquid helium. And there it was. There was my Josephson junction. To say I was excited is to put it mildly. But anyway, that I really felt, no, we have a solution. And so I took it out of the cryostat and I just put it on my desk. And literally it was a blob of solder about, I don't know, centimetre long and had this sort of piece of wire sticking out of it. And then the next morning, Brian Pippard came in and he said, well, how's it going? And I said, very well. And then he looked at what I left on my desk and he said, John, it looked as though a slug came through the window and expired on your desk last night. And so the slug it was. So I had to think up the acronym for the slug, and it's the superconducting low inductance undulatory galvanometer. And this little toy, it revolutionized what the voltages that you could measure. And Brian Pippard had wanted me to do 2 times 10 to the minus 15. I probably could do 2 or 3 times worse than that. But I was on a voltage scale that was just unreachable anywhere else in the world. And that really started my career. It is. I think because, first of all, people may get together with different disciplines. And for example, some of the things that I'm proudest of doing involve a collaboration with, for example, geophysicists. And I've figured out, using my very sensitive devices, how to revolutionize how they could use geophysics with my very sensitive detectors to search for minerals way down below the surface of the Earth. I worked on, I think one of the most important things also is I worked on magnetic resonance imaging. And we figured out, again, because I was working with people in medicine, how to make devices that were able to measure magnetic resonance images at much lower magnetic fields than had previously been possible. And these had very large improvements in sensitivity, for example. And I think those are 2 examples of how people can come together from different disciplines. And they both have new ideas, and if they put them together, then it can really revolutionize things. Now, of course, the best example of all this is the reason I'm sitting here. That's because in 1980, a graduate student, someone who had been an undergraduate at UC Berkeley, decided he wanted to stay on to become a graduate student, and in particular he wanted to work with me. And his name was John Martinez. And a couple of years later, then I had an application from someone in France who wanted to become a postdoc in my group. And his name, of course, was Michel Devereux. And so this was an extraordinary combination of people. And, they had individual strengths, I had an individual strength, and we just got together. What was very important was that at the time, there was a brilliant physicist who'd already got a Nobel Prize, and his name was Tony Leggett. And Tony Leggett was at the University of Illinois, Champaign-Urbana, and he had asked a very, very, very important question. And he said, is it possible that macroscopic circuits can obey quantum mechanics? And this is an incredibly important problem, because we all grew up learning about quantum mechanics and how, for example, you have atoms. You have a hydrogen atom, and it has a particular structure, and it has energy levels, and all kinds of properties that were understood unbelievably well. And Leggett said, okay, now, for example, instead of something that's a tiny atom, 1 or 2 angstroms across, if I took something the size of my thumb, a circuit, could that still obey quantum mechanics? And I think the world said, oh, of course not. But Leggett was very intrigued by this. John Martinez and Michel and I thought, wow, what a question. It's probably not possible, but maybe we should think about it. And so we did. And it was a very challenging problem, not least because in order to try to answer that question, you had to do the experiment at very low temperatures, which it was possible in those days, and still is, using something called a dilution refrigerator. And we did experiments typically at about 20 millikelvin. And these are tough experiments. But anyway, we worked away, and John and Michelle had great talents. And finally, we got it to begin to work. And it was very interesting in the fact that we first of all published one set of results in Physical Review Letters, which is the sort of, the most challenging experiment. It's typically a three-letter article, three-page article. And so we wrote an article about one particular question that we thought we could answer. And that was published in Physical Review Letters on October the 7th, 1985. And then there was another aspect of this problem, which we had also, we felt, solved. And again, it was required that quite challenging experiments. And that we published 3 weeks later on October the 28th, 1995. So there were two Physical Review Letters that we published in rather short order. And that answered the other half of the question that we needed to answer. And the reason I'm sitting here talking to you, and I'm sure you'll interview John and Michelle as well, was because of those two short papers. And it is a remarkable coincidence that that first Phys letter was published on October the 7th, 1985. And the day that I got the phone call at 2 o'clock in the morning was on October the 7th, 2025, 40 years to the day since we published our first paper. And I always thought this was the most extraordinary coincidence, but that's what happened. Over the many years that I've been running a research group with graduate students and postdocs, I've had 104 postdocs and graduate students. And I think that they also taught me a very great deal. And I've always been very grateful what I learned from them. And we published many papers together. I recently published my 499 publication in a reviewed journal. And I think that I'm hoping to get to 500 soon. But I think that those are a reflection on the contributions of these many people who worked for me. And also, of course, many other faculty members in other universities. And Michel Devereux, well, of course, was in my group, but he and I have published a lot of papers also since then.